Hi, everyone. I'm Chris Callison-Burch. I'm a professor in the Computer and Information Science Department. My area of expertise is on natural language processing, which is the subfield of artificial intelligence that's most related to large language models like ChatGPT. So I'm going to give a quick walkthrough of some of the OpenAI technology so that you get a sense of how it's working. What I'm showing now is the Playground, which is a web tool that allows people to interact with the OpenAI API, which will allow us to call things programmatically. So if I were to develop a piece of software that wanted to make a call out to ChatGPT or to GPT-3, I could prototype it within this Playground and then extract a piece of code that I could call via the API in order to execute that in my own software. So I'm not going to show you the software aspects of it, but I'll instead first just walk through an example. So at their most basic, large language models are very similar to what your mobile phone is trying to do when it's trying to complete what you're typing. So a language model is trying to predict what the next word is. So I can type in an example, and Michael Kearns makes fun of me for this because he thinks it's like Googling yourself, but I always have the system write a student review for me. So I can say, my favorite professor at the University of Pennsylvania is Chris Callison. And because I have a unique last name, my full last name is Callison-Burch, then it should reliably predict what the next word should be. In this case, it should be Birch because we've prefixed it with Callison, or Chris Callison. And I can press submit, and it'll generate what it thinks is the most likely next word. And it not only tries to generate a single word worth of completion like your smartphone is doing, but instead it's trying to generate a whole paragraph. So this process of predicting one word based on a context, that's a probabilistic language model. And then continuing along where you continue to generate adding a single word each time, and then adding the results to the context that you're conditioning on to predict the subsequent words is called autoregressive language modeling. You're trying to continue what you've already predicted in the past. And so for those of you watching online with the video component, you can see that this output has colorization. Or I guess for those of you listening via the podcast, so I input my favorite professor at the University of Pennsylvania is Chris Callison. And then the model continued to say Birch, and then it continued for a whole paragraph. It said, he's a professor in the Computer and Information Science Department and is an expert in the field of natural language processing. He's an incredibly engaging professor who's passionate about his work and shares his enthusiasm with his students. He's a great teacher and has a wealth of knowledge that he is always willing to share. He also encourages his students to think critically and is always available to answer questions and provide guidance. He has a great sense of humor and always willing to make the class fun and informative. So it writes a complete student review for me, in large part because of the context that I gave it. So I said, my favorite professor. And then the interesting thing is it's trying to generate each word according to a probability distribution. So for those of you watching online, if I mouse over one of these words, I can see what probability it's assigned to it. So let's say we want to look at what I'm an expert in. So in part of the description that it's output, it says he's an expert in the field of, and then if I click on the next word, we see that the first two words are actually just different capitalizations of the word natural for natural language processing. So almost all of the probability mass is centered on natural for natural language processing. So it looks like 96% of the probability is on natural language processing being my field of expertise, which is exactly right. The only other ones that have any probability mass assigned to them are the word computational. An alternate name for natural language processing was also computational linguistics. It's a little antiquated now. And then machine, which could be for machine learning, or machine translation, which are also fields that are adjacent to my own. So one of the remarkable things about these models is that they've encoded some information about the real world in their parameters. So when they're trying to predict the probability of the next word, they're conditioning on this history that we've given them. And the fact that it's learned to associate words and concepts with my name and with the University of Pennsylvania is almost miraculous in my mind. Like the fact that it's encoding any true facts about the world is just flabbergasting. And that's in part due to the huge size of these models. So GPT stands for Generative Pre-trained Transformer. The transformer is a kind of neural network, and in this case, the number of parameters that we've used to represent the neural networks are getting incredibly large. Like we're on the order of 500 billion. Probably by the time you listen to this, Google or some other outfit will release a trillion parameter transformer model. And just for reference, the number of neurons that you have in your brain are about 90 billion. So we've already surpassed the kind of analog of number of neural computational devices within one's brain in terms of number of parameters of these large neural networks. So they end up learning facts about the world, although there's no guarantee that what they produce is going to be factual, because they're really just saying what word is likely to come next, and there's no fact checking, no cross-referencing against Google or checking of any sources whatsoever. It's all just this notion that we're going to generate the next word by drawing a word from the vocabulary in proportion to the probability that this statistical language model has assigned to it. So I can say, I can give an example of this by continuing this paragraph and giving a biographical fact about me that the model often gets wrong. So I can say or I'll even say Professor Callison-Burch received his PhD from, and then I'll have it complete. And it says that I received my PhD from Stanford, which is incorrect. I got my PhD from the University of Edinburgh in Scotland. I did do my undergraduate degree at Stanford, but I did not do my PhD there. So this is an interesting instance of where these models can produce very plausible sounding text that doesn't correspond to any factual element to the world. So because we're talking about a professor from computer science, it's very likely, according to the model, that a professor from computer science in general may have received their PhD from Stanford. So it's saying Professor Callison-Burch received his PhD from, and it assigns 42% of the probability mass to the word Stanford, 10% to the word the. So for some universities, we say the University of Pennsylvania, for instance, 13% to Carnegie for Carnegie Mellon University, which is a top 3 computer science program. And then the remaining the next most probable is about 6% towards University of Pennsylvania itself. So this, I think, highlights one of the really important things to keep in mind about these models, and that's at the moment, there's no guarantee of factuality in what they're generating. The output is really just this, I'm sampling words from a vocabulary according to the probability distributions that this language model has learned. That generates very plausible sounding text, and it's really remarkable that it generates plausible sounding text, including things that are semantically coherent and grammatical and all sorts of really interesting aspects that are that have been tough in the past for computers to handle about language, but it's not generating factual information. I've had a little bit of a debate with Michael Kearns about whether or not this is a solvable problem, whether or not the ability of these models to be constrained to generate factually accurate information is going to be solved in the near term. Michael thinks about this in a very philosophical way and thinks that this is going to be nearly impossible. I think about it in a very practical engineering way, where I think that there's a relatively straightforward solution to a part of this problem. It's not a complete solution, but that's to retrieve information from the web first and then generate based on that. So for instance, if I gave the model a little biography that I had retrieved via Google of myself, then it should accurately generate information about where I did my PhD based on that biography. Another limitation to keep in mind about large language models like OpenAI's ChatGPT is that they are pre-trained only up to a certain point in time. After that time, the information that they encode about the world in their model parameters becomes stale. So they can't speak about current events without going out and accessing the internet. So I'm showing an article on my screen now from the BBC about the European Space Agency postponing a mission to the moons of Jupiter. So I could say to GPT in the OpenAI Playground, I can say, what happened to the European Space Agency's mission to Jupiter? And it should say that it doesn't know. So I type into the OpenAI Playground, what happened to the European Space Agency's mission to Jupiter? And then it gives me information. It says the European Space Agency's mission to Jupiter, the Jupiter Icy Moons Explorer, acronym JUICE, is scheduled to launch in 2022 and arrive at the Jovian system in 2030. The mission aims to investigate the atmosphere, magnetosphere, and 3 of Jupiter's icy moons, Ganymede, Callisto, and Europa, for clues about the formation and evolution of the solar system. After its arrival, JUICE will spend 3.5 years studying the Jovian system before its final mission phase, when it will fly close to Ganymede and attempt to land on its surface. So it gives me information that's now out of date. So it was trained, it knows about the European Space Agency's mission to Jupiter. It knows really good facts about it. It's learned that and encoded them in the model parameters. But now this article says that JUICE has been postponed. So what I'm going to do now is just copy the text of this, and I'll put it into the context of the system to allow OpenAI's API to allow GPT-3 to then use it. So I'm now giving it a prompt that includes this whole newspaper article, which is about 1,000 words long. And then I'll ask it the same question as I did before. Now it's able to condition on this contemporary information that I gave it, and I'm asking it what happened to the European Space Agency's mission to Jupiter. And its response now says the ESA has postponed a planned launch to the satellite. It now says the ESA has postponed a planned launch of a satellite to the planet Jupiter due to unfavorable weather conditions. The mission, known as JUICE for short, will aim to establish that the planet's moon could sustain life. The 8-year journey from et cetera, et cetera. So now it is able to take that information into account. The really great thing about these models, or one of the really exciting things about these models, is essentially we can use them as a question answering system, which used to be a first order research concern in natural language processing and was an incredibly challenging task. So given this article, we could say any sorts of questions like, what will the JUICE mission be looking for? And we're again giving it the newspaper article from today's BBC, and it'll say the JUICE mission will be looking for evidence of conditions that could potentially sustain microbial life in the oceans of Jupiter's major moons, Callisto, Europa, and Ganymede. It'll also be looking for evidence of organic materials on the surfaces of those. Then I could ask a question like, how long will it take to get there? And then it'll say the mission is expected to reach Jupiter's major moons by July 2031. It will take 8 years to make the journey from Earth to its destination, with a series of flybys of Venus and Earth required to slingshot the mission out to its intended destination. Cool. So that's an example of how you can use the same technology that we use to write that short student review of me in order to do other interesting natural language processing tasks. So this is a really exciting direction that this field has taken, where the basic technologies of large pre-trained language models, where the mechanism is you have some context, some prompt, as it's called, and then it produces a completion through this process of autoregressive generation of the next word that's most probable based on that context, can be used for a huge range of tasks. We can use it to perform question answering by giving it a newspaper document and then asking questions about it, and then it will generate answers that are plausible based on that context of that newspaper article. We can also do things like machine translation, where we give it an article in Russian and ask it to translate it into English, or cross-language question answering, where we give it that same Russian article and we say, please answer questions about this, respond in English, and it'll do so. Another really exciting direction for these models is they do instruction following. So in addition to prompts and completions, many researchers have trained these models to do tasks. So they give the prompt as an instruction in natural language of the type of task that they want to be done. And then they give a completion at training time of an example of how the model ought to follow that instruction. So you can ask it to write an essay about the Lord of the Flies that summarizes the plot and includes details about the symbolism of the conch shell. So now I'm asking it to follow some instructions to write an essay to a certain specification, and then if I press submit, it'll generate what it thinks is a probable completion of that instruction. So it'll say, The Lord of the Flies is a classic novel written by William Golding in 1954. It follows a group of British schoolboys stranded on a remote island and their attempts to survive and create a society. The novel examines the idea of human nature and how it can be corrupted under certain circumstances. The novel starts with the boys, led by Ralph, making a makeshift camp and gathering food. So it goes on to describe the plot for a few paragraphs, and then in the end it says, the conch shell is an important symbol in the novel, representing civilization and order. As the novel progresses, the shell begins to lose its power and importance, signifying the boys' descent into savagery. In the end, the conch shell is destroyed, symbolizing the boys' complete loss of civilization. So this is really cool. This is instruction following. It is writing an essay for me based on this novel, based on what prompt I gave it, and it's able to follow those instructions. Of course, this likely strikes dread into the hearts of high school English teachers around the country, because now it feels as if students, both high school students and college students, like the wonderful students that we have here at Penn, could potentially cheat by using this kind of technology to automatically generate responses to our homework questions, to our take-home exams, all sorts of potential for an activity that's sort of like plagiarism. And one of the kind of crazy things about this is, because this model is generating new text each time I press the submit button and have it generate, it'll generate an entirely new, different essay each time I press the submit button. It's sampling from the probability distribution, so it'll continue to talk about the Lord of the Flies and the symbolism of the conch shell and the plot of the novel, but it's going to use a different wording each time I press submit. So if you're watching online, I'll just show a couple of examples of this. I can even regenerate using this little recycle button. So this one starts off, The Lord of the Flies is a classic novel by William Golding that follows the story of a group of boys, and then I'm going to regenerate. And now it says The Lord of the Flies is a novel by Nobel Prize-winning author William Golding. It is a classic story of a group of British schoolboys. So again, it's starting off the essay completely differently than the first two times that I did it. And each time it'll slightly change the wording. So William Golding's The Lord of the Flies is a classic novel that has captivated readers since its publication in 1954. So the problem with this from the perspective of professors is if we wanted to forbid our students from using this kind of technology when they're writing essays, our ability to detect the machine-generated text is going to be limited because the current plagiarism detection software that we use or have used up until this point looks for overlap between two essays. So we have plagiarism detection software called Turnitin that will compare a particular student submission against all the other student submissions from this semester, and in fact against past semesters and texts that we've retrieved from the internet, and look for overlap in the wording. So it'd look for long stretches of text, long phrases, sequences of words that are identical in order to previous things that have been indexed by Turnitin. This ability of the models to generate a completely new worded essay each time you press the submit button, each time you generate, breaks that model of plagiarism detection entirely. So there's really interesting research into how we can go about trying to identify the origin of text and whether it's been generated by machines or generated by humans. And there's both the there's both a challenge. How could we do this automatically if we wanted to have a plagiarism detection software? Or what is the ability of people, of us as human beings, to be able to distinguish between machine-generated text and human-written text? Could we tell upon reading this essay that it was written by a machine and not by a human being? My students and I have interesting research into this. We recently published a paper at the AAAI conference, the American Association for Artificial Intelligence, called Real or Fake Text, investigating humans' ability to detect boundaries between human-written and machine-generated text, where we went into detail. We did the largest study to date about how well people can spot machine-generated text. And the two very high-level takeaways from this piece of research are, one, it's getting much harder for people to detect that text was written by a machine. As these models get larger and larger, their output gets more and more plausible, which means that when we go from GPT-2 to GPT-3, it's become harder for people to spot that it is written by a machine. And when we go to GPT-4 and presumably to GPT-5, this is going to continue, presumably, so it'll be harder. But we also found that people can be trained to spot the text. So we did a control group study with my computer science class, my artificial intelligence class, which has 500 students enrolled each fall. And we split the class into two. We had them play a game that we created, which you can try out for yourself. If you wanted to go to our game, it's Real or Fake Text. It's at the URL roft.io. And then you can play a game where you read a piece of text sentence by sentence, and then tell us for each sentence that we display in turn whether you think that was written by a human or written by a machine. So we always start out with a human-written sentence. So I'll just do a quick example here. So we have a human-written initial sentence. Murray Perea began his Great Performers recital at the Avery Fisher Hall on Sunday afternoon with a group of Bach choral preludes as transcribed by Bosconi. And then it starts with a quotation mark and says, "I've always loved Bach," Mr. Perea said. "I love Berlusconi's transcriptions." So I'm going to say that looks human written so far. And then the next sentence is, "The pianist played the preludes with a light touch and a sense of humor." I'll say that's probably human written. "He was particularly effective in the last prelude, which he played with great delicacy and tenderness." Yeah, sure. I'm going to say that's human written. The audience responded warmly to his performance, but was not as enthusiastic as it had been for his encore, Schubert's Ave Maria. Now, if I were a music expert, I would know whether or not Ave Maria was indeed written by Schubert. And if I knew that it wasn't, then I could say that this was machine generated. That's a typical error that a machine might make. But because I'm not an expert, I'm going to say, okay, maybe it's human written. But I also think this wording sounds kind of weirdly, so here's my reasoning. So the current sentence says, the audience responded warmly to his performance, but it was not as enthusiastic as it had been for his encore. So to me, this is weirdly worded because an encore happens after the performance. So the way that this sentence is worded, it suggests that the encore has come before the performance. So I'm going to say this is machine generated because I believe that's a logical error that violates my common sense. So if you're playing this game on your computer, once you mark a sentence as being machine generated, we'll ask you why you think it is. So here I've said it contains common sense or basic logical error. Then it'll reveal to us whether or not I was correct. And in fact, that was a machine generated sentence, but I missed the earlier machine generated sentences. So it switched immediately from human written to machine written. So it took me 1, 2, 3, 4 sentences before I reliably detected that it was machine generated. So I get some amount of points for guessing close to the boundary, and then I would get more points if I guessed exactly at the spot that it switched. So in our large-scale study in this real or fake text paper that was published at the OpenAI conference, we looked at these two groups, one who we trained to see how well they could detect and where we provided extra credit in proportion to how good their scores were. And the other was a control group where we just gave extra credit for completing some of the tasks. And we found that over time, the group that was provided incentives to learn how to detect ended up getting better. So compared with the first few times that they played the game, their final scores were much better. So they were able to reliably detect that boundary. They were reliably able to spot when we switched to machine-generated text better than their cohorts in the control group. Now we've seen a couple of the different abilities of these systems. We can complete sentences. We can perform question answering. We can ask the system to follow instructions and do things like write an essay. A big question is, what's the future of this technology going to be, and how will it impact us, my colleagues' careers as educators, and how we'll interact with students? How will it impact people around the globe in terms of the abilities that it might be able to do and the jobs it might be able to replace? And I think it's a really exciting time for this technology, and it's a very uncertain time. So there's a lot of potential applications for this that could be really amazing for advancing technology and advancing how we interact with computers. But it also feels like a very dangerous time in terms of the potential for societal disruption and displacement of jobs. I feel like the United States has a long history of job displacements where factories get automated, work gets outsourced to less expensive regions of the world. And by and large, that has affected blue-collar style jobs where it's affected factory workers and that segment of society. But we haven't yet experienced a large-scale displacement of workers in the white-collar sector. And it feels like this kind of technology could have the potential to have that disruptive effect on white-collar jobs as well. So I'm personally super excited about this technology. I'm fully embracing it in my own courses, and I believe that students should learn how to use this and that we shouldn't forbid it for fear that it's plagiarism or something like that. We should teach the students how to use it effectively, understand its limitations. I'm all in. I'm going to use it in my own courses, but I am admittedly a bit scared about the future. I do not know exactly what will happen. I don't know if this is going to be a societally disruptive event or if it's going to be something more similar to the kind of fizzle out experience that we had with self-driving cars and the predictions about their likelihood from 5 years ago. So 5 years ago, I had a similar fear that the large segment of the U.S. economy that's dedicated to driving jobs, whether it's for transportation or for jobs like taxi cab drivers and Lyft and Uber, would potentially shortly be displaced by self-driving technology. That turned out to be incredibly difficult and hasn't yet materialized, so those jobs are currently safe. I don't foresee them being displaced in the same way that I did 5 years ago. So I've been wrong in the past. I hope I'm wrong again. I hope that this technology doesn't come along and make paralegals go the way of lamp lighters in the old gaslight lamps era, but it is something that keeps me awake. Okay, well, I hope you enjoyed this little introduction to GPT, the technology that underlies ChatGPT, and I encourage you to try it out yourself. If you want to try some of our own work from here at Penn, you can go to roft.io and try out the game to see how good you are at spotting machine-generated versus human-generated text. Thanks, everyone.